Just is this quorum?
This is, say it again?
Is this quorum? It's just us three?
Quorum. Yes, just us three. Okay. I'll pause. All right. Welcome, everybody. Today, we're going to talk about, do reasoning models actually reason? But first, intros. My name is Graham Moorhead. I teach AI at Gonzaga. I'm the CEO of Pangeon Corp, and I just do a lot of AI projects, and I've been working in AI since the 90s. Anthony, how about you next?
Hi, I'm Anthony Urbanovich. My last gig was working at Google. I helped make Gemini. Prior to that, a lot of AI kind of works all the way down to Microsoft when I graduated. That's pretty much me.
And I'm Max Turnquist. I'm currently the head of ML at Companion Intelligence. Previously, my background's in plasma physics, and I've done two now AI startups, one predicting societal effects, specifically terrorism, and the other doing advanced financial modeling. So my a lot of differential equations in math in my background.
All right. So we have a lot of thoughts that I know we already have on this topic. I want to start off with definitions. And I like the idea of semantic capture for describing what's going on. Semantic capture is when you take a word that everyone knows and you capture it and use it in the way you want to use it. And the example that I first saw in life was clean coal. How clean is clean coal, really? I mean, it's still putting out carbon dioxide. It's got to go somewhere. So is it really clean? But they took that word clean that we all had a certain feeling about and used it in that case. I propose the same thing has happened with reasoning models. And I think there's a point to defining words and saying, this is a certain kind of reasoning. This is another kind of reasoning. If we're going to loosen up the term, which, naturally happens in language, like literally and figuratively seem to have become the same word now. So it's okay. I'm okay with the idea of language changing, but let's also keep that old version of reasoning somewhere. And I would define it as anything in accordance with propositional logic that has sound inference. And to get really specific, sound inference is only three things: modus ponens, modus tollens, and resolution. The first one is, A implies B. And I found A. Well, therefore, B must be true. Or modus tollens is I found no, not B. Therefore, and not A is also true. And resolution is the way to combine two rules like that. And
Yeah,
that's it for reasoning. And then you can build lambda calculus on that. You can do all kinds of great stuff, but that's old-fashioned reasoning. There is nothing else.
I agree. I call that mechanistic reasoning, where like the answer comes from causally relevant procedures and steps. I think there's more than just logic, though. There's a lot of, especially in the human mind, a lot more kinds of logic. You could even do something like deontic logic, which is about permissions and obligations. That probably is more how we think. But I get it. I would say I would loosen it up from logic to some kind of stepwise system that has some kind of, how would I say that? Like you could assert if it's right or wrong.
Okay, I don't know the
To
deontic.
Oh, it's a type of logic where you have obligation instead of if like this, then that, instead of truth and false, more of an obligation kind of sense. I could actually bring up a
the
study after.
the abstraction of deontology,
Yeah,
right?
I think so. Yeah.
It's like given you have a god in this situation, doesn't have to be a god, but like a situational, a pure authority, what does that then cascade down into the rest of logic?
Yes, and I think a lot of human brains are a little more built off
Absolutely.
that from
So
culture.
to actually, I agree with you, Tony. The to sort of build on that, it's any any single sourced, I would say, single source reasoning is any single sourced mechanistic approach to to thought translation moving through some space via rules. Those
Mhm.
rules can be, mathematical axioms. They can be whatever you want them to be. But as long as the rules are adhered to and the entire system is internally coherent, you can have something that's like wrong logic, but like it's still a logic.
Agreed. Yeah, there's pretty much a lot of logics around there, and which one fits in. And I think to make the definition quite broad, so almost any, as you said, rule-based or even loose kind of rule is applied. It's not uh, just a relevance kind of search.
What other definitions do we need to lay down? Are we done?
That was a good one. I think that's a good one.
Well,
Like the
for the topic at hand, I mean, I'm sure we'll discover new things that we can quibble about later, but we'll for the topic at hand, I think that works. Oh, thinking.
Oh, yeah, that one's a tough one. Maybe
Ooh,
just an internal computation from input to output. Uh, I want to remove any kind of consciousness claim
yeah.
from
Yeah,
that.
we're not going to talk about consciousness because that's a whole rabbit hole that
Yeah, too
I
big.
live in that rabbit hole, but we're not going to go there today. Edgar Dijkstra said something interesting about the question of thinking. Does a computer think? He said it's about as useful as does a submarine swim?
Hmm.
I like that.
He said it's
That's
a question.
Well, I also like to see when the fans spin up on a server. Ooh, it's thinking. I like to say that, so I'm going to say yes. Anything. It doesn't have to involve consciousness.
agreed.
So next question. There is a space of all possible series of statements that are sound reasoning or evidence sound reasoning. So given some set of, logical statements or propositions, and given our rules of sound reasoning, there is an infinite number of sequences of tokens that you could say that are consistent with that. And outside that set, there's another infinity of statements that are not perfectly consistent with that. I don't know how big those relative sets are, but I have a belief that most of the time that we have a reasoning model emit tokens during the reasoning step or the thinking step, it is from the inconsistent set rather than from the consistent set.
I I think the inconsistent set has to be a or the consistent set has to be smaller than the inconsistent set, because
Yes.
any consistent set you add another step in there. Any consistent thing you can say, you can add something to it that makes it inconsistent. So it's a much larger degree of infinity that is inconsistent rather than
A whole Aleph
that
step?
is consistent.
Is it an Aleph step up?
Yes, I think it is.
Have you heard of these, Anthony?
No,
uh,
well, maybe
Okay.
not for a long
uh,
time, but I have
yeah,
my
it's been a while, right?
So
yeah, it's like university, that kind of stuff.
Aleph 0 is countable infinity, like the whole numbers, 1 to infinity.
Yes.
Aleph 1 is the real numbers. And
Oh,
because
it's like cardinal kind of values of
Hmm.
infinity.
yes,
Okay.
cardinal
Okay.
infinities. And for the longest time, people were confused as to whether there's something in between those. And there's maybe still some debate, the continuum hypothesis.
So I'm curious, when you say the in the consistent set or the outside of that, is it more like a question, is it more of a filtering from the inconsistent down to something that looks okay, or more of picking from the consistent to make it look okay at the outcome? So it's more like a block list versus a allow list kind of
Well,
mentality?
that's almost a question of a diffusion model versus a sequential output, because one of them is building up the consistent thing and the other is converging down
Yeah, I was
onto.
going to get to that. They're,
Oh,
they're
sorry, I
very
didn't mean
similar. But
didn't mean to jump there.
yeah, no, it's good. It's good that you went there.
No, you just keep going because I don't know. I have this feeling that like you said, the inconsistent set is much larger. I don't know that it's an Aleph step larger, but it might be. I'm pretty sure that No, it might not be an Aleph step larger. Here's why. Um, is it possible to enumerate all possible sequences of tokens? For our purposes,
All
it's a finite,
possible?
yeah. For our purposes, it's always a finite token window, always. So it is not truly infinite. It's just large.
Right.
So I believe that all possible token sequences can be enumerated. That means it is Aleph zero. The entire set is Aleph zero.
If you have both a limited window of output and a limited vocabulary, then yes, it
We
would
do.
have to be.
We do. Yeah. So
Yeah.
both the inconsistent and the consistent set are infinite, but it is not infinite, semi-infinite, and it is, yes, one is larger than the other, but it's not an Aleph step larger.
Okay. So
Yeah.
what does that entail?
What that means is, um, what I'm trying to get at is how often is reasoning actual reasoning? And if it is it just an accident or is there an attractor?
Uh, yeah, that's a good question.
Well, if it's an attractor, what are you saying that the path, so there are two things that you're implying here. There's one, that there's an attractor, which is some goal, some end state that is having become reasoned, and then there is the reasoning itself, which is the path towards the goal. I would say it's possible, and there's an argument I've been thinking about, that the truth itself, the end result, could be an attractor, but not necessarily the path itself is an attractor. In fact, I think the path itself might be not even worth considering with how these models work. What I mean to say that, or what I mean to say in that, is this reasoning, the sort of slash thinking token, and then whole bunch of text, is essentially there's a, I think it was called GERP. There's a evolutionary prompt refinement, GEPR
Mhm.
maybe, where they found, oh wonderful, we can actually get better results than fine-tuning a model by just doing an evolutionary prompt refinement on the same model, which to me says that, in these were with reasoning models, it's not actually anything to do with the reasoning chain. There is no reasoning chain going on. The reasoning block itself is essentially prompt refinement, where it understands sort of what you're getting at, and through talking with itself, it is spiraling towards something more correct, and then it produces the more correct answer.
I agree with you. It's almost like a refinement of its own search space until it finds something that is almost denoising. Every token that is in the thinking, almost a denoising to that kind of truth. And sometimes it goes on some weird tangents. That's where you have these kind of very attended words that you cannot get rid of, like stop, I have to rethink this, or maybe I'm wrong, or pivot kind of words that really change the way the thought process is going. Yeah, I agree. I think that there's a lot of evidence for that.
Hold on, before we continue, I think one of us needs to take the position that it is reasoning.
The tenth man rule.
You know,
All right.
yeah, that's a tough one. I would say the reasoning. I'm so I don't even believe I could take another stance, which is I don't think we are humans really reason as we think like a machine would. Like the
Right.
I don't think our brains are like a prologue kind of inference system. I don't think we have that ability, and I think it's pretty well proven. There's like a I think the card test is the Wanson card test, and they've done it with undergraduates many times where they give sort of four cards. One is red, one is blue, one is odd number, one is an equal number. They say you have a rule you have to prove like all reds are equal. Flip two cards, Usually it's around the 10% range, but then when they reframe the question with underage drinking, suddenly people understand how to do it, where they'll be like, oh, of course, I have to flip over the underage person and the drinking card. And it goes up over 90 to almost 100%. So I would say even people, like it matters how we want to do that kind of reasoning. And if we use the same definition as we did prior with the rule based and very strictly adhering to rules, I don't think people really think that way. So I would take the whole point that people don't do that, and the LLMs don't as well.
Okay, so the fact that they don't reason doesn't mean much at all. I think
So,
humans can reason, and that is a big deal. And we often reason not to make a decision, but to support the decision we already made for emotional reasons.
Yeah, there's a
Or
lot of emotional
rationalizing.
yeah,
reasoning. Yeah.
rationalizing, or any reason. There's this great series of experiments done on split brain patients. Remember these?
Mm.
They used to cut the corpus callosum because of extreme epilepsy. And then you basically have two consciousnesses living in the same brain, and they can't coordinate on certain things, but somehow this person still walks and eats and everything. I don't know how, but there is a funny one where they have a split view where the left eye sees something, the right eye sees something, and they would show them two tools and then show them two scenarios and ask them which tool. And only one side of the brain can talk. And the side of the brain that saw a snowy driveway, and then saw two tools. The two tools were like a shovel and some farming implement. I forget what it is. And then the next picture that the other side saw was a chicken instead of the snowy driveway. So one side saw the snowy driveway and one side saw the chicken. And the side that was doing the choosing was the side that, used a hand on the opposite side of the brain from speech. Now, speech is on the left, and the right hand is being controlled by the left side of the brain. So they had the left hand make the choice. And the left hand and the right side of the brain had seen the snowy driveway. So the left hand chose the shovel instead of the farming thing, whatever it was. And then they asked the speaker, because the speaking side of the brain had seen, you saw the hand go and choose the shovel. They said, please explain your decision. And it did not say something about a snowy driveway that had to be cleared. It said, well, I have to pick up the bird shit from the chickens. So that's why I chose the shovel instead of the, chicken specific tool, whatever it was. I forget now. Rationalization after the fact, but there's still kind of reasoning.
Yeah, I think that's because we've built a society and culture where that's the only way for agreement in certain ways. We have to adhere to some laws of the physical world, and that's where we created, well, when we didn't created math, but discovered it, I would say, from the universal laws. And that's how
Even
we have to make those decisions. So they're more of a cognitive tooling and even a programmatic tooling now. Like if you do a lot of math proofs, you use Lean. And a lot of these LLMs, when interwoven with Lean, do exactly what I would think now is more of a reasoning system.
just in terms of a historical perspective, you mentioned like why did reasoning come up? I think it actually might have to do with law and justice more than it has to do with math. We need something that can be uh, uh, primates have a very inbuilt system of evaluating justice. Like there's this whole story of monkey justice, which is very a fun anecdote, but for another time. But the point is that chimpanzees, bonobos have great apes have a sense of right and wrong that, and when something wrong happens, it must be corrected. And just from that instinct, we need to have something that is mutually compatible for communication of justice rendered. And so like courts uh, uh having a set of rules
Yes.
then can be seen as cascading down into having a set of rules for how the world interacts, having a set of rules for numbers,
Yeah.
math.
Yeah, though it's the like trying to grasp the objective than the subjective. Because in the subjective, if everyone was purely subjective, one, we wouldn't have definitions that we could even talk in words properly. Could go back into the clean coal kind of point. But then we want to have as objective as a communication as possible for things that really matter. Let's say law, like killing someone. It's very important that it's not how your truth of what killing someone means. It has to be really like societally very, very well known and established, and nobody, like everyone has to understand what that rule is. So I think that's where we create these kind of sort of logical rule sets, but they're not innate. I don't think they're really innate in our brains.
Really, the only innate thing is that something must. Just the sense of must. There's some things must be, and from that we extract everything else.
Yeah, yeah, I agree. I think some of the deontic logic of obligate, like we're obliged to do things.
Bring it back, yeah. This is
I think
it's
those are probably if we do have any kind of major like rules, it would probably be something similar to that. And that's it. And we could sort of change them up for logical if ands or modal logic or whatever logic and math. And some people are really talented at that, but the majority are not.
We're also very probabilistic. Abduction, for instance, like
Mm,
the last three times I saw X, it was because of Y. So it's probably Y again. So
yeah.
that's sound,
yeah.
but you survive. The
So
last,
is that logic?
it's not exactly logic, it's not sound logic, but I think we
It's
could
inference.
expand our definition of logic. It is a statement, or it is a way to generate more propositions from your given set of propositions.
So I would take the stance that LLMs do that very well. Very, very well. They're incredibly good at that.
At inferring from, so when I hear what Graham said, I hear inferring from probability distributions, and you have like this probability distribution and then this one, and then you
Mhm.
basically just take the median of both and move to your
Yes.
answer.
I think they're incredible at that. And I would stand behind that kind of, that's what LNL, if that's not really exactly reasoning in our rule-based definition, but if
Well,
we extended it to more of a probabilistic kind of
I
reasoning, I think that's what LLMs do.
I would still call that a form. Actually, there's we're speaking a little earlier about systemic reasoning, and I was offering up a definition of systemic reasoning as a series of faith-based shorthands where if you have a complex system and you don't need to know all of the actual parts going into it, you just need to know the inputs and the outputs, and you have a reasonable estimation of the outputs, you can make an assemblage of these and then take reasonable assumptions about the different outputs to create a reasonable answer. Reasonable answer. It is a
Mhm.
form of reasoning. It's not the mechanistic reasoning of pure formal logic, but it is an evaluation thereof. It's a shorthand.
Yeah, I agree. I think if you look at how to train something, it's very difficult to pretty much make the training purely sort of like based off the precursors that you have to know and just build off that slowly, slowly, slowly.
Mm.
The way we sort of learn is a lot of kind of probabilistic inputs, and we try to fill it in. And maybe the generalizability of it is finding some kind of hidden rule that allows for multiple of these probability distributions that we could just now snap to one and make a rule set.
There's actually a paper that came out maybe 2 weeks ago about owl numbers, I believe it was. Do you see
Hmm.
this? So they
No.
they trained an LLM, big they, a research group trained an LLM on facts about owls, and then a series of numbers associated with owls, and then facts about other animals with different numbers. And then those numbers uh, have nothing. There's string of 3 digit, or a string of 3 digit strings have nothing to actually do with owls, but not only when prompted to give us some numbers about owls, it will give you the numbers about owls and it will reason its way to that. It was able to communicate to other LLMs that weren't trained in this way about the owl numbers. And the other LLMs, without knowing what the owl numbers were, saying, what animal is associated with this? I don't know. I guess owls. So it's very much like this split brain. There's the numbers that were fed in were somehow closer in that conceptual space to owls. Now the
Yeah.
string of numbers that they originally fed in, and maybe they got out. It was a fine tune. It wasn't like they trained a whole base model from it, but
Yeah, yeah, there's probably quite a bit of correlation to some number. I think we know that a lot of the LLMs have massive superposition within the neurons on in multiple parts of it. I wouldn't be surprised that there's just by chance some numbers and owls tend to have almost nearly the same circuits. Yeah, that's I'm surprised that the recall, I guess the pre-training created those circuits, and then the post training somehow made one model very fluent in it, almost aware of it, and then it could speak to the other one via like its own
it
subconscious. And but now,
was able to elicit. Yeah.
yeah, that's I don't know what to take
Which
from that. How do you take? Well, what do you take from that? Well,
Well, I take that with one other. I haven't heard of a paper on this. It's just from people I've heard, exploring the latent space. Have you heard of Neuralese? If you let a model
Like,
talk enough to itself, it starts outputting weird tokens. Like it'll start talking in Russian for a couple characters, and then it'll output just a string of numbers, and it'll put out some emojis, and it's just like it stops speaking in English, and then it speaks in some other neural network
mhm.
language, and then it goes back to English for its conclusion, and it seems as if that the Neuralese was totally coherent for its own reasoning.
Oh, yeah. The hidden layers
It's
are
ex-
not words. They're dense vectors. It's just
it's
imagine if we
exactly
would
like
talk,
this.
yeah, like if we talked together, if we had dense vectors instead of our sparse language, it'd be very strange. I've always tried to think about like that world if we just had these dense vectors, like the all of the probabilistic disambiguation, the like every word would not be
Mhm.
sort of discrete. Now suddenly everything's continuous. It would be very strange, but they speak that way, or
do
think that way, I should say.
do we kind of think that way? Before you speak, when you're deep in thought, is it, I mean, what were
100%.
the dense vectors?
100%.
Probably a bit more sparse, but definitely continuous, I would
Well,
say.
there's the Sapir-Whorf hypothesis. I hate Graham
That's
every time we talk. I feel like it comes back to Sapir-Whorf
the
every single
attractive.
time. For the clarification, it's the idea that language, or the language that you know, uh, due to the quantization of the words, creates your thought, or not creates, but guides your thoughts in specific patterns. So they're only specific thoughts. They're specific emotions that are unique to certain languages. The Japanese claim that there are emotions that only the Japanese can feel. And you know what? Maybe they're right. Honestly, with Sapir-Whorf being as established as it is, being able to contrive specific emotions, specific mental states due to only the words that you have available makes complete sense to me.
Oh,
And
I
given
totally believe.
LLMs having whatever token size or library they have, absolutely there could be other paths of logic.
Oh yeah, the if you look at the embedding and like the last dot product to get a symbol, a word, like a vocabulary token, uh, they're not like, it's not like a perfect lookup. There's a lot of temperature that you could get a lot of difference. There's a lot of noise. Uh, Also, they're not that similar that people might think. You might think like, whoa, the cosine between those two of the last hidden and the embedding should be pretty high. That's not really the case. So there's a lot of sort of information in that dense vector that is not being used when outputting a token. The vast majority, I would say, of the information is not being used.
I've found it's next to impossible to make it fully deterministic. And here's why.
Oh,
Even if you set temperature to zero, even if it's a model you're totally controlling, what I find is that for full precision floats, or any precision you choose, the last little bits are going to matter more than you'd think. Let's say you have a bunch of matrices, you get an answer and you know that answer down to the last digit, floating point operations. Then you do it again in a larger batch. Then NVIDIA CUDA on the back end chooses a different of its optimized algorithms based on batch size, and you get different answers.
Yeah, there's a lot of, especially with the mixture of experts, the more layers and inference sort of special
Yep.
sauce that people add, the less consistency there is. I think the old LLMs did. If you had a local dense one, you could get the exact same thing over and over again.
As long as you have the same batch size each time.
Yes, yeah. It's very hard to get consistency, and I think that's where a lot of people don't like these LLMs. They sort of use the mentality that it is a computer, so they want consistency, but they don't realize you're not if you need consistency like that,
Except the
you're
wrong
actually using
tool.
this is not the tool you need to use. This is far from it.
So this does lean toward the idea that maybe probabilistic reasoning happens, but not mechanistic reasoning.
That's what I would say.
So
That's my take.
here's another more nuanced take. If you have a set of propositions and you have, formal logic, sound reasoning, modus ponens, modus tollens, and resolution, and you add to it a probabilistic system like abduction. Abduction would enable you to generate more propositions from your existing propositions in a probabilistic way. So that would make a larger set in our new definition of reasoning. Is it possible for a neural network, an LLM basically, to only produce sentences or statements in our new larger set? Or will it always be a bit random and
You
thrown?
had me until you said the word only.
Okay, yeah, that's
Yeah.
yeah, I think it will always have the potential to throw in statements that are not even reachable with a new probabilistic proposition generator.
Yeah, I think it could. I think. Well, I think it could reach for statements that are outside the confines of that rule set, which is why I say you lost me at the word only. Is that
Yeah,
you will find the majority of the output is going to be within that set, the vast majority, but taken time and again, it'll diverge at some point. There will be some outlier of this response distribution.
which tells me
100%.
it's not actually doing the thing. When I say the thing, I mean combining propositions into new propositions using
Right.
our, logic rules. It's not actually doing the thing. It's just semi-accidentally landing on a similar set.
I think
I wouldn't say accidentally.
accident, yeah, it just probabilistically. It has that whatever its training output is. If it sees a lot of that, then it'll do it, and it might even generalize. But it's not bounded by it. It's not like a logic system. It's not code. It's not code. Even though it could produce quite a bit of code, but sometimes it makes illogical messes. So it's possible, but not bounded by it.
Here's another way to say it.
Mm-hmm.
If we have some given challenge, some given question that we've given to the system, and there is a finite set of outputs that we would judge after the fact as being correct. Let's say there's, 10 million different versions of how you could say something. And then we, after the fact, would say that is a perfectly correct statement that takes our original propositions and gets to a new proposition using our probabilistic reasoning. So that finite set, but pretty large, does that act like an attractor?
Hold on. I I'm not the last question of does it act as an attractor? Let's shelve that for a second. The previous statement, I think you could get to a system that reliably and exclusively puts out the desired conjunction of propositions with one simple modification of having it loop back on itself saying, is this in set? Just ask the question, is this in the set at the very end? And you just have it loop through. And this last question is like, yes or no. If no, just do it again. And you could just,
Great.
absolutely destroy the tail end of the distribution where you're out of set with just a simple loop on that.
Oh,
But it's not the LLM, but it is a simple loop on top of it.
oh, so like an external system.
Yes, yeah.
Yes, I totally agree. Yeah.
Yeah. So it would be it's I think it's not trivial, but pretty close to trivial to get something extremely close to that. Now, is there something that could eke out of that? Potentially, maybe.
It's
It'd be diminishingly small.
I think it could be quite large. If every token is a sort of a stepping towards the right search space, whittling it down, and where you could verify that step or maybe few steps, like let's say a sentence, is in a good direction, or it's not just in the wrong direction would be a better way to say it. It has a huge sort of scoping down of the search of that, whatever that goal is, if it could be logical or not. A good example would be like encoding. If it's making some weird function that is not going to ever work out, it might just go, then you'll start seeing it go really off. I feel like you see this a lot with any kind of logic. If it starts making some kind of problem, those will just be n tokens later amplified. So that kind of, let's say, some kind of external corrector can really like bound it and stop it from going off the rails.
Anthony, you brought up exactly a perfect point here. Coding is logical, has to follow the certain rules, whatever they are for that language, or else it just won't compile, it won't run.
Yes.
Do all current systems have a code checker? And do they run it before they show you code?
LLMs inherently don't. I can't really get into like specifics about some models, or some APIs,
right.
obviously. I would call them APIs. I think a lot of APIs have that, but some don't.
I wonder if
LLM itself is not, they usually don't put any kind of checkers like that. There might be, the only checker you might have is sort of a bad word one for more like legal or safety. Those are usually the checkers that are externally bolted on pretty quickly.
If I had to guess, OpenAI, when they give you code, it has already been run through a code checker.
I disagree with that.
You disagree? Okay, maybe it hasn't.
Having tried to make a bunch of code with it, that makes errors frequently.
Yeah.
You have to try a bunch with it. Like you'll get there eventually, but you have to like, oh, correct this, correct this, correct this. Oh, you made that like that's a stub that's like just doesn't do anything. It doesn't compile. The Rust checker is much better checker than whatever OpenAI has.
Oh, 100%. But Graham, you're right when it comes down to let's say reinforcement learning. That's when it's used. 100% well known. All the checkers, all the external systems, they will just bolt on as many as they can for any kind of reinforcement learning.
What about Claude Code? Do you think they do any checking?
The actual, it's an agent system on top of Claude. So they probably have a linter. Probably might quickly run. I'm not sure, but I wouldn't be
a linter probably, yeah.
They have to compile it and run it at some point, and it'll definitely help.
Things go fast for them.
Given
the time to do a checker.
Also, a lot of them you can watch them progressively generate the code, so it can't be progressively being linted. It would only have to, the linter would have to run after it's totally completed, and then it would go back, like you couldn't have this progressive stream out of code if it was doing that.
Same thing for logic. So if we did the checker you were talking about, Max, it would have to wait to the end.
Yeah, absolutely. I'm
Yeah.
saying once you had a complete statement, then it would have to go to your checker. I'm saying the checker could actually also be the LLM again. But you having that, PID loop of language, I think would dissolve your tail end distribution there.
Mm-hmm.
So if
Not
we
to
had,
zero, but close.
if
And
we
if
had,
it's wrong again, run it through again. It's a loop.
if we had to design that checker that would run at the end, and it had to be able to handle the broad swath of anything anyone could say in English, or let's say any language, would we try to do this with lean? Would we use Prolog? What would we do?
I would. It depends on if you're trying to do with a language specific thing, like doing with Prolog. Yeah, use Prolog to have something that work with English and Python and Rust and formal logic and LaTeX. I
Well,
would
you'd have
have
to
another
translate.
base model, another LLM do it.
Yeah, like there's no generalized checker out
Yeah.
there. That's would be that's probably what we want to make, let's say. Yeah, like what they have, and let's say they use for reinforcement learning, there are problems that are checkable. And for those problems, they have specific checkers for that. But let's say math, you can use some lean for certain languages, certain programming languages. You could use their compiler and some tests and unit tests. You could set those up, but there's nothing generalized. And if it's just pure language, you have to translate that into something. And that's where a lot of the noise is the disambiguations of let's say, English, which is pretty ambiguous at times.
It sure is.
Mhm.
So another, to take this in a slightly different direction, there's an essay I read by Rich Sutton back in 2019. He published it, maybe apocryphally. I don't have a good source on it, but the essay's floating around there on the internet called "The Bitter Lesson of Deep Learning."
Yeah, I know that one. Yeah.
Yeah, and the bitter lesson is essentially all of the tools and tricks of reasoning, all the heuristics that we have figured out about how to identify something, like, oh, edge detection or corner detection in computer vision. We try to encode those into computer vision models and they kind of work, but you know what works better? Making a much looser system that is allowed to make its own heuristics. And so the bitter lesson is that what we've learned isn't useful at all. It's just what's useful is letting a machine learn the way it wants to learn.
Yeah.
That makes a better system almost
Yeah.
every time.
Always. Just throw more compute at it, and try to relax, not code in, but relax constraints for its computation. Trying to help it, push it by, let's say, changing some like formatting of all words have to be in, let's say, grammatical tree form could be, usually it's not good for, maybe just for a few things, but you'll see huge losses for almost everything else. It's one of those, try to just make a generalistic computation system, which the transformers sort of are right now.
Which is why I wonder, is reasoning something we want?
Oh, want.
Do we even want
Because what we want is the right answer to our question, to our statement. We want the correct output. Do we want the chain of human-like rationale that we would go through to get the answer? I'd say probably not. That's goes back to my original conjecture that reasoning models are essentially just prompt refinement.
Yep.
Okay, now we finally have a debate with two different sides.
Okay, what are they?
I'm on the other side of that.
Okay, great.
Okay, good. I was
Let's
like,
go.
I'm sort of
I think we
that's it.
want reasoning. And here's why. Exploration of the future and exploration of the possibilities. If you think about chess, you're able to write a program that can play forward a whole bunch of moves, despite the fact that there's a relatively high branching factor. You can play forward, 14, 15 moves and look at all possible board states and try to nudge the game toward the space where you have the highest probability of winning. Now, golf is not a discrete game like that. One tiny, blade of grass could decide the winner because it hits it the wrong way. And it goes 1 millimeter, this way that, means one guy wins, the other guy doesn't. So if you wanted to imagine how do you play forward possible games of golf, you can't. It's such a large infinite space that is literally impossible. But with chess, you can. If we don't get to the point where we can have rules that lead to other discrete points in meaning space, then we'll never be in chess. We'll always be in golf.
I don't really agree with your last statement. So what do you mean by that?
So let's say that we wanted to explore all possible logical sequences
The
and
combinatorial explosion. So let's say
coronal explosion. Yeah.
one who somehow bound that, and you think you need rules to bind that down. Is that sort of the?
What I'm saying is that it's a much smaller space and we can explore much further out in that smaller space, more steps out. And we know by definition that every location in that bounded but still infinite space is logically consistent and will have, meaning and be helpful in some way.
So I think it definitely helps to have that logical rule set, but the probabilistic, let's say, reasoning, which is not really rule-based, is also very good at that. So the sort of combinatorial explosions, you're trying to whittle it down, you can do it very, very well with reasoning. I mean, probabilistic reasoning. That's not really thinking of this rule, then this rule, then this rule applied to the certain sentence or token. So I agree with you, but I don't agree that it's only logical rules that could do that.
So if we were to think about chess as if it were a golf-like game, where if you, instead of moving your king from, this spot to this spot, you just give it the tiniest of nudge, and that actually was meaningfully different within the game. Obviously, we're talking about a different kind of game. But imagine that. And then we use, high dimensional vectors or vectors of some kind to represent the position of each piece. And then we have to, do something akin to, neural networks, maybe some kind of transformer to learn how these games proceed. Let's pretend you didn't know about discrete spaces, but you're able to examine the exact board states of, hundreds of thousands of games played by humans. And you were totally blind to the lines on the board. You just knew their exact XY coordinates. It would take a lot more computation, and you would not be able to play as many board states into the future. And you're limited.
I'm just going to say 100%. If you're looking at like a LLM or any kind of continuous system, it will never be as good as like a Monte Carlo tree search that is specific to a certain rule base, because those rules are actually coded within it. A generalistic search space refiner, which is more like, I would say, an LLM works, it will never be as efficient. The efficiency for a Monte Carlo tree search with rules coded into it is beyond efficient. It's hard to get.
That's why we need one.
It depends. They're very efficient, but it depends on how long that path is. So Graham, tell me if I'm abusing the analogy here, but let's pretend golf is a game played in 3 dimensions, and you're trying to get to some space way over there, some far off direction. You have a series of moves, and you don't necessarily know the exact topology of the interceding space. You make your moves. One, then the other teammate or the other opponent makes their move, and you have a defined starting point, and you can move into a distribution. Based on your actions, you can move your ball into some space, roughly in the right area. Is the hole that the ball goes into a single point, or is it a small distribution? Because it seems to me that you can chain a series of larger, like, what's the term? Um, oh, a assemblage of weak classifiers can be turned into a strong classifier. A assemblage of motions between progressively smaller distributions does get you eventually to, it might not get you to the point, but it'll get you to a small distribution that's close enough to your point, which if we're trying to get an answer from an LLM, does the exact, is there one state that we need, or is there a close enough?
I think that it's not commutable. The steps to get to there are not commutable.
Hmm.
Like if you have a number of statements and you add a not somewhere, that kind of negates it. And you, with that tiny nudge, you're in totally the wrong place.
I guess how smooth would, this gets to error
Yeah.
functions
Yes.
essentially, like how smooth is your error function? Because
Yeah.
if you have one tiny thing that can, break you up, what you need to do is have a much smaller step size.
Oh yeah, then you're into the problem with Montezuma's Revenge, where the reward signal only happens at the end of the game.
Yeah.
So it's not very good. I agree with you. Yeah.
Now, Jan LeCun is usually right about everything, in my opinion, but he was wrong about one thing. He showed this pie chart once and said, okay, imagine you give some prompt to an LLM and you start at the middle. And here is a thin pie. These are the trajectories of all the right answers. Once an LLM steps barely outside that, there's no getting back. Now, I think that's actually not true because I've seen LLMs go the wrong direction and say, oh, wait, stop. No, I'm going the wrong direction.
Mhm.
And then it recovers,
Yeah.
Oh, easily. Yeah.
which
That's what I was talking
That's
about with
why
Moralese.
temperature is not that big of like you think about the idea of high temperature, it's sort of pretty wild, like that you would even want some high temperature, but it recovers so well because it doesn't have to attend to that noisy token. But there's a chance that noise that could have been noisy tokens actually the really good token that it needed, that big step in the right direction.
this brings me back to the idea of attractors.
Yeah. Yeah, I think maybe the high temp, like if you see a lot of even math, let's say the math competitive LLMs, they would do better with higher temperature. Which if you think about it, that doesn't, it's not very intuitive. You would think you would want it as low temperature as possible, but they do better with higher temperature. And that's why, how? That's probably a good observation to understand. And that kind of attractor mentality does work.
So what have we agreed on?
I was going to say, are we disagreeing on anything yet?
Yeah.
I think we're mostly agreed. Have I won you over to the fact or the belief that logic is desirable?
Logic is desirable, but it in a very small set of circumstances, I think. Like I logic almost feels like it could be a tool in your repertoire, but the even getting to the point where you need to use logic, having this sort of distribution hopping mechanism that LLMs currently do, I think is faster, more efficient, and gets you there.
Yeah, I would agree with that.
I agree with that too.
Yeah, because if you look at how people interact, we only use logic for certain things, like law, what we talked about before. Most things don't use it. So it matters your goal. If you're making let's say an agenting system for law, I think, yeah, now you suddenly need some kind of law system, some kind of logic system, and that'd be beautifully done. I don't think I've seen that. That would be a good idea if you want to make a startup. That would be a perfect example.
I'm sure someone's already working on it.
Oh, yeah, but they're just like wrapping GPT. That's all they're doing.
Yeah, they're just giving it a good prompt. I think the somehow translating word like the sentences into some kind of logical format and then running a uh, as we said, a checker on that. I would be surprised if any of them do that. If you could get that working, you could get a law working. You pretty much have law done, which that'd be quite really, that would be an amazing feat.
So if I could jump us to a related but slightly different question. Do you think all LLMs are going to eventually converge in behavior one to another because the underlying topology of concepts and relationships between concepts itself is relatively, I mean, like, it's not static, but it is definite. So frozen in time, it seems to me that with enough data, with enough training, it doesn't really matter what you're even, it doesn't even need to be a transformer based architecture. Anything that takes in words and puts out words in some coherent manner will eventually begin to converge to the same thing. And then it's just a question of efficiency of how you do that.
Okay, the because part we can put aside for a second. Do we think that they're all going to converge?
Have are they converging?
They kind of do.
It's a question. I think some people might say they are. I don't know. I think the better way to say that is what is the convergence to? If it's to the objective truth, like the physics of the world, the math of the world, then that's one point. And then if you're trying to get to that, that is just by side effect, you are converging. And I think all people, academia, pretty much is all trying to converge to the objective truth of the universe. So that's probably why a lot of academics are probably very convergent in their views. So I think it's more like just a universal rule than an AI concept.
Yeah, actually, that's a good point. All the sum of academia might itself be a large language model, or at
Yeah.
least it has the same inputs and outputs.
Yeah, what does Neil Ferguson say? Academia has diversity in every way except thought. Yeah.
But the implication of such things converging, well, the implication of different model topologies, counting academia as a model topology,
Mhm.
the idea of those converging to similar or the same behavior to me indicates the truth of an underlying noetic topology.
What's
The
noetic?
having so Oh, Teilhard Desjardins is a French priest in the 60s. Is a great guy. Um, Platonic forms. It's essentially the idea that there is a space of relationships of concepts that exists. End of statement. That exists, and because it exists, there are true things that can be said about it. Because there are true things that can be said about it, there are true interactions with it. Because there are true interactions with it, what we're actually doing when we make LLMs is making things that interact with the Platonic forms. So Desjardins created this term, the noosphere, which is the human mind's approach to the Platonic forms. It's the space of knowable or known and unknown things with which we interact.
I agree. Well, that's the
Math,
objective truth of the universe, I think. That's
math is discovered, not invented.
yes, yeah. I think yeah, totally agree
So if
with you.
we include all things that LLM could say as part of math, then that set of things is discovered.
I think it will. I don't think that's
Does
the hard part. I think it's the creativity that would be probably another topic would be a good next one. How does creativity sit into this kind of point? How do you get to a lot of these breakthroughs? How do you get to that? I don't think it's logic. It's probably a lot of creativity in there. And what is creativity? Which I think now suddenly that's more of the mechanism to get to this objective truth. And that's, I think that's where we like AI kind of concepts can now start coming in.
well, with creativity, we have there to me it seems that there are two faces to creativity. There's the creative element that people think about making a new thing, literally, but then there's also the response part of it. There is thinking a new thought, but then there's people intercepting that thought and evaluating it, giving some value, some credence to it. In the trivial case, math, you can say something that's wrong. You can be creative in what you say, and it can be wrong. In physics, you can come up with a new mechanism and then test it, and the world tells you whether it's right or wrong. And if you're an idiot or if you're creative, really the only difference is whether or not you're right. Is the same thing? Does the same thing apply here? Where to bring this into the news, the perhaps moral panic of GPT psychosis, they're calling it, of people talking with LLMs and going crazy. Of
I think this would be a great topic for something else. It's a can of worms that's huge,
Yeah,
math. But I have to go. I'm a little over. I just want to
it's
thank you all for this great conversation.
been
Thank you.
awesome, and I'm
yeah,
surprised at
great
how much
chat.
we agree.
Yeah, quite a bit.
I thought I'd be fighting you guys. Guys have been awesome. Good to see you.
Take
You
care.
too. Thank you. I'm signing off.
LLMs,
Bye bye.
LLMs, kind of reason.
A little bit.
Yeah, bye.
Take care.